both at Yahoo. Philip, if you didn't know, started working with the YSlow team a long time ago. He helped develop Boomerang, which is a very commonly used tool for measuring performance. And he's moved beyond Boomerang and with SOASTA. He's got a lot to tell you. I still go to him as a guru. We were just talking about on-touch versus on-click with mobile. I mean, if I have a question, this is the guy to go to. So please welcome Philip. Thanks, guys.
Thanks, everyone. Can everyone hear me? Just testing. All right. So, like Ted said, I'm Philip. I work at a company called SOASTA. And I work on a product called Impulse, which does performance measurement using Boomerang. There's the URL to Boomerang there. It's open source under the BSD license, available on GitHub. So by the end of this talk, I expect everyone to be submitting patches. I hope. Impulse, there's also a link there to Impulse. Like I said, we do measurement, realism measurement, so for all of our customers. But I'm specifically going to talk about the open source Boomerang that you can take and implement on your own site if you don't want to use a commercial offering. And specifically, I'm going to talk about single-page applications. So the room service and spas thing is kind of a fun story. I was doing a kind of predecessor to this talk in Stockholm last year, and they wrote this whole article about the RAM service provider the RAM service that we provide. Except in Swedish, the word RAM, R-U-M, translates to room. So when they translated the article to English, I became the world's foremost room service provider. And now I'm into spas as well. So if you like how this is going, go ahead and check out our project. So what does a page look like on the network? This is the Intuit.com website. I opened it in Google Chrome, opened the network panel, and took a screenshot. Essentially, you'll see a lot of, there's the initial page download right at the top, and then there's a whole bunch of resources. It looks pretty optimized, a lot of things happening in parallel. So that's good. You see a lot of things happening in parallel, and then I don't have the actual numbers there, but we see fairly quickly the whole page loads up. So the question is, this is how it looks on the network, right? We see how it looks on screen most of the time, but this is how it looks on the network, to the browser, to the and we want to know how do different browsers handle this. So this is really how it looks in Chrome. Does it look differently on different browsers? And that really depends on how different browsers handle parallelization, whether they can handle scripts and CSS in parallel. So there's a website called Browser Scope, which has user-generated content. So you run tests on your own browser, and they curate all of that. Tells you for different browsers and different versions of the browser what's the parallelization like, and other features. So looking here just at the network tab, we see Chrome can handle 6 connections to a single host name, and it can download scripts and style sheets and all in parallel. But all of these browsers cannot handle scripts and iframes in parallel, right? So there's some things that they can do in parallel, some things that they cannot. And really these things affect performance, right? When you serialize requests, that makes things slower because you're waiting for one request to end before the next one starts. But when you parallelize them, it makes things appear faster. So the number of parallel connections, that's 6 in most browsers, 35 in the case of IE9. I think that was an experiment which did not last long. As you see, IE10 went back down to 16. So these things say how much parallelization is going to happen from a single host name. So you might think that we want to split things across multiple host names, and really if you're doing multiple third parties, that's going to happen anyway. The question is, which of these resources affect perceived latency? And that's really what we want to measure. Because eventually, as we saw in the previous talk, there was it's perception that matters. Right? It's not how long it actually takes to load things, it's how long the user thinks it took to load. So you might have a really fast page, but if you're waiting to render everything with JavaScript, then the user's just going to be waiting. Whereas if you might have slow loading page, but if you have interesting things happening on screen while it's loading, the user is going to be more interested. So we find out that static JavaScript files and CSS files are the main things that block the rendering. Right? If you have static JavaScript, your page is going to wait until the JavaScript loads, unless you say that JavaScript is async. And if you have CSS, even if your whole page is loaded, it's not going to render until all of the CSS is loaded. So you may want to do things to make sure that those things load fast or they load asynchronously. Now these can also be single points of failure. So if you have JavaScript on your site loaded statically and the JavaScript doesn't load, what happens? Right? If it doesn't load fast, that's actually a good thing. But if it doesn't load slow, or it loads really slowly, like it takes 60 seconds to load up, your page is going to be waiting 60 seconds before it renders anything. And the same with CSS. So let's take a poll here. Who owns a website? It could be a personal website as well. All right. Who has like a Twitter widget or a Facebook widget or Google Analytics on their website?
Well, Facebook and Twitter's.
All right. What happens to your site if one of those servers is down? Right? Does your site also go down? So now is the performance of your site dependent on these third parties?
It could fail gracefully though.
Does it fail gracefully?
Well, you could design it to
How?
have a perceived. No, like if Facebook is too long.
All right. So yeah, there are ways around it. So you want to make sure that if you're dependent on third parties, you actually put them out of your critical path so that they don't affect performance. If those services are down, it doesn't affect your site going down. Right? And there are various ways to do this. I could go in for a whole 1 hour talk talking about how we do that. But this talk is not about that. This talk is about measurement and knowing exactly how long these resources take and which ones are affecting you the most. So, is anyone familiar with the navigation timing API? All right, a couple of people. So for those of you who are not, navigation timing API is something available in most current browsers, all except for iOS Safari. Actually, I have a slide here saying who supports it. So we see almost all browsers today support it, except for iOS Safari. Opera Mini is not counted because that actually renders on Opera servers, so it doesn't matter how long things take to load up there. All the others are real user browsers, and Safari just added support in version 8, and then they pulled it out in 8.1 because it had bugs. But they have added it back into 9, so that's good news for all of us. So what navigation timing does is it gives us information about how long the page took to load at various parts of its loading cycle. So when the user initiated a request, either by typing in a URL or clicking a link or clicking on a bookmark, right, that request starts. And what the browser does is it has to do various things. It needs to do a DNS lookup. It needs to open a TCP connection. It needs to first check if that resource is already in its cache. Then it opens a TCP connection. It may need to do SSL negotiation over that TCP connection, then make a request. If that response has any redirects, has to follow those redirects, and then finally get to your content. So it goes through a whole series of steps before it gets to your content, and that's what the navigation timing API tells us. It tells us when each of those steps happen. So you can see here, there's all of these different stages of a page loading. So this tells us when a complete page loads. Now, whose website is complete, has multiple single pages today in 2015? My blog actually has multiple single pages.
What do you mean by multiple?
So you click a link, it opens a new page, and so on. Versus a single page application. Right? So there are still many websites that are multi-page applications, but we're moving more to a single-page application scenario. So navigation timing is great when you have multiple pages because you click a link, it opens a new page, you get a new context, you get new navigation timing information. You can collect all of that and send it back. And that's what Boomerang does. It collects all this information. It also does some hacks for browsers that don't support navigation timing, and then beacons it back to your server, where you can then do further analysis on the data, either sending it to Google Analytics or sending it to Pivot or using a service like Ampulse. The Ampulse server collects that information and does analysis on it and provides you with aggregated data. So what we really want to know is, well, what do we do with that data, right? So some simple things you can do in JavaScript is just looking at how long did it take for this page to load, looking at load event start minus, load event end minus load event start. So we go back to this diagram, you see here it's, where's that load there? So there's load event end right here and load event start right here. So that's how long it took from the first byte of the content coming in to the last byte. And we could just as well do load event end minus navigation start to get the entire load time, or DNS end, domain lookup end minus domain lookup start to tell how long it took to do a DNS lookup. And if we aggregate this across millions of users, we sort of get a good distribution of what those load times were at different components and where we might have bottlenecks, where we want to optimize. Right? Now, newer browsers, so newer than what we saw in navigation timing, also support something called the resource timing API. And resource timing, what it does is for every single resource on your page, so that's all the scripts, all the style sheets, all the images, it creates this kind of an array of them telling you timing information for each of those objects. And it can give you fairly detailed information like redirect time, DNS time, TCP time, but only if it's from the same domain. So there are various privacy concerns, like somebody could figure out where you've been just by measuring the time it took to load a particular image. So for those reasons, you actually only get the total time by default. So that's the time from response end. So start time to response end, that's what you get by default. And if it's on the same domain as your website, so like if you're intuit.com and you're loading images from intuit.com, then you'll get detailed information for that. Because it assumes that you are the owner of the website and of this resource, so you have permissions to do that. Right. But what happens if you're running a CDN? Right? If you're putting all of your images onto a CDN, it's typically served from a different domain. So you run into the same problem where you may not get the entire load time. So before I go into all of that, let's look at some fun things we can do with resource timing. So you could obviously generate a RAM waterfall, which is what we're doing with Ampulse, or a performance heat map, which is something that Mark Zeman over at SpeedCurve is doing. And let me show that to you. I pulled up the website. It's so there's a link on that. So there's a link there which has a bookmarklet, and if I click on that, it tells me when every single image loaded. So you see it sort of puts a heat map of all the images and different components on the page. And it says this one took, what was it, 1884 milliseconds. Or rather, it finished loading at the 1884 millisecond mark, and it took 534 milliseconds to load up. So it might have started, and you can see down here the white lines. It tells me when these things actually finished loading. So this one loaded at 1356 millisecond mark, it only took 21 milliseconds to load, and so on. So it's a pretty cool thing, just overlay on a page. So if you're a developer working on a page and you want to do your automated testing, you can sort of run this kind of a script to just see if you're regressing or not. Right?
When you say image loading, is it from the cache or from the server?
It doesn't matter. Wherever it's loading from, the resource timing API will tell you how long it took to load. So this is using resource timing API, which is what I showed.
Tell me if it's loading from cache.
You can guess that it loaded from cache, so that's why I have another point.
Oh, okay.
Cache hit ratio. So basically, if the network time was 0, you know that's loaded from cache. You can go back to this image, and there are various things you can guess. Like you can tell it loaded from the app cache by looking at domain lookup start minus fetch start. Typically, that's 0 because it takes almost no time to load from cache. So if your entire duration was 0, then you know it's most likely loaded up from cache. There's very few exceptions where it's 0 and not loaded from cache.
Local.
Sorry?
Local file.
You can also identify problem resources, right? So one of the things we really want to do with measuring our pages is find out what's actually causing performance problems. So if you take all of the results on your page and say, all right, what's actually contributing the most to my page load time? My page load time is 5 seconds, and I have one particular image that's actually taking 5 seconds to load. It's most likely that's the culprit that's affecting my page load. It may not be as simple as that, right? You might have like 3 scripts which are each taking 1.5 seconds to load. And so they might be adding up together. So you want to do the analysis, see whether they're loading in parallel, loading serially. Is there a particular domain that's consistently causing you problems across all of your page loads? So doing that kind of distribution analysis on these various domains can also help. But there are some limitations with resource timing. So if you had a failure on DNS lookup or TCP connection or some other kind of timeout or a security error, typically if a browser blocks a resource from downloading because of any of these errors, resource timing will just not report on that. And the reason for that is it does not know if you have permission to load that particular, look at the timing information for that resource or not. So it actually needs to get a response back from the server to know if you have permission to read that or not. There's inconsistent reporting of 4xx and 5xx errors. So this is something where you actually get a response from the server, but different browsers handle it differently. So in the case of Chrome, which turns out is what we do all of our testing on, there's no resource timing information. So I initially assumed that browsers just did not report this. It turns out that Firefox and Internet Explorer, which are the other browsers that support it, do so differently. In the case of Firefox, all timestamps are non-zero, but the duration field is 0. Right? So whereas in Internet Explorer, all timestamps are non-zero, so you actually get some timing information for 4xx and 5xx. It depends on whether it's same domain or not to tell whether you'll get detailed information or not. And also, it doesn't tell you if a response is a 3 or 4, which is no. So we send a conditional request, right? Saying, send me this content if it's been modified since this date, or if something else is modified. And the response comes back saying not modified, which means you can actually use the cached version. At that time, you don't know whether the response was a 3 or 4 or a 200. All you know is that something happened and I got a response. Now this is kind of weird condition where it hasn't really, well, it's loaded from cache, but it's loaded from cache after making a network request. So you know there was a DNS lookup probably, there was a TCP connect probably, because you don't know if those things are already established or not. And there was a download definitely because it has downloaded headers, but it's not downloaded any content. So the load time is going to be different from when it actually loaded content, because it's loaded headers from the server but loaded content from the cache. So it's kind of one of those weird situations where you don't really know whether this number you got is right or wrong. And you might have to do other analysis to figure that out. So my advice to most people is generally don't ever get into a situation where you're responding with a 3 or 4, which means never set a last modified header on your content. And always set an expires, but never set a last modified and never set an Ajax header. So that just makes sure that the browser will never send a conditional request. It will either read from cache or it will make an unconditional request to your server. There's another thing called cross-origin resource sharing. So there's a header you need to set. So like I mentioned in the case of the CDN, if you have a server that has one domain, and you're loading content from a CDN, which is on a different domain, you still want to measure that the time it takes to load content from that domain. So what you do is on your CDN domain, you set a header, a response header called timing allow origin. And you can either specify an actual host name there, saying timing allow origin intuit.com, which means intuit.com is allowed to read the timing information for these resources. Or you can say timing allow origin star, which means any site is allowed to read the timing information. Right? Typically, if you're running your own CDN or your CDN provider gives you the service, they will put in your domain there to say that any scripts running on your domain can read the timing information from the CDN. But if you're a third-party provider like I am, then you just set it to star so any of your customers could read timing information. Essentially, you want your customers to be able to tell how long you are taking to load so that they can hold you accountable for slow loading third-party widgets. So we do this for hours, for our resources. If you go to the Impulse domain and try to download the JavaScript from there, you'll actually have this and you can measure how long it takes to load. So this is all fine. This is great for multi-page apps as well as single-page apps. You can measure how long different resources take to load. But what you really want to measure is how long does it take when a user initiates a request and that's loaded using something like HTTP request. How long does it take to measure? So read through this code. Can the guys in the back read it?
I can't even.
Alright, I was just kidding. You don't need to read it. So in short, I'm assuming it was not worth reading, but you proxy the XML HTTP request object. Right? This is fairly simple to do. And I'll show you some code later that's actually readable. So you proxy the XML HTTP request object, intercept the open and send calls on that object, and you would capture all the events that fire on that object. So typically things like the ready state change or the loaded event or timeout. I'll give you the actual events later. So just a warning, all the code that follows is simplified versions of the actual code. The actual code, as you saw on the first slide, I should say this is also a simplified version of the code. So I'm going to show you a simplified version of the simplified code. It works in most modern browsers. It will not work in 100% of the browsers. That's what the complicated code is for. So I'm going to break it down. Just the proxy part. So how do you proxy XML HTTP request? And you can get this code from Boomerang. So if you go on the GitHub site, you can download it and read through it. But essentially what we do is we capture window.xml HTTP request, save it in a proxy object, an original object, create a new proxy XML HTTP request that has a bunch of things. So it creates a resource object, it hijacks the open and send, creates a new request object, which is actually the original XML HTTP request object that the user would have called normally, and then return that. So it basically runs very fast. It doesn't do anything heavy. Right? All it does is swap out the original object, create the object that the user would have created, and return it. Right? And then you set your proxy to window.xml HTTP request. So now whenever the owner of the page creates a new XML HTTP request, and this works even like if you use jQuery. jQuery internally calls new XML HTTP request. This will do the same thing. AngularJS, a lot of other frameworks that use this will end up using the proxy version and not the original version, which is what you want. And then in here, you want to define the new open and new send methods, which I'm going to show you right now. So the send method is fairly simple. Takes a timestamp right at the beginning, so that boomer.now is a Boomerang convenience method. All it does is it's a wrapper around performance.now. Is everyone familiar with performance.now? So modern browsers, the ones that support navigation timing, have a high resolution timer. And if you call performance.now, so if you open your browser like Chrome and go to the dev tools and type in performance.now, it'll give you a high resolution timestamp of right now relative to when navigation started. And that's typically in microseconds. So it gives you a very good resolution. But for older browsers, what this will do is fall back to new date.getTime. So it'll give you milliseconds from the epoch. So essentially what boomer.now does is it figures out the best way to get you the current time and returns that. So it gets you a timestamp of when the XML HTTP request started. Essentially when the user calls send, that's when the request went out. And then it just calls the original send. Now I need to mention one caveat. This proxy that we've defined, it works in all browsers except Firefox has some proprietary extensions to XML HTTP requests where the constructor takes in a config object. It does not work in that case if you have Firefox using that proprietary method. Now, no other browser supports that, which is why no website actually uses that, right? Except maybe Mozilla's website. I don't know. So we felt it was safe to do it this way. We also do a few checks that I haven't shown you to find out whether XML HTTP request actually exists or not and what version it is. And the reason I don't support that special Firefox version is because I couldn't figure out a way to override a constructor that takes in arguments. Or rather, you cannot read the arguments object from a function that intercepts a constructor. It's kind of it gets very strange at that point. But you can intercept arguments from a method call. So what we do is once we intercept the send, we just call the original send, which remember we proxied here, so we got original open is equal to original send is equal to requested send. So we can call that original send method with all the arguments that were passed in, and this will just make the original request as if the user had called. So again, this is very lightweight. All it's doing is taking a timestamp and then doing what the user wanted to do. So it should not add much overhead. There is a little overhead for taking the timestamp, but not a lot. The open method is a little more complicated, and I'll actually just put comments in for a lot of the parts which are complicated. But essentially, we get the URL that we're making the request for because we want to save this as the resource that we're requesting. Now we're doing something interesting there. We do a document create element and anchor. So we create an A element on the current document and then assign the URL to that. And the reason for this is many times when you're doing XML HTTP requests, you'll use a relative URL. You won't use an absolute URL because of the same domain policy. So this needs to be resolved to an absolute URL because we might need that absolute URL later on. Also, one very interesting thing we found out with jQuery is it actually sets a base href at the top of the page, which changes what relative URLs are relative to. And if you don't use this, you'll actually be taking something that you think is relative to the root domain, which is actually relative to base href. So doing all of this, and that's why you need to set document, use document of the current window, and not of any iframe or anything else. It has to be of the current window so that the correct base href is used. So that will take the resolve that URL to an absolute value. Then we check whether it's async or not. The default value of async is true. So if the user doesn't pass in async equals true, you need to assume it's true. And the reason we need to know if it's async or not is for any XML HTTP requests that are not asynchronous. So synchronous ones, you cannot actually set a ready state change event handler, right? Because it's synchronous, it's basically going to block, and the whole JavaScript runtime is going to block until the resource comes back, which means your handlers won't fire until the end. So you only want to set that ready state change handler if it's async, and then you want to set handlers on the load, the timeout, error, and abort events. So there are 4 other events. Now, all of these are considered terminating events, so load, timeout, error, and abort. If any of them happens, you need to terminate your timing information and say, all right, I'm done, nothing more to do. Whereas the ready state change is a little different. It tells you intermediate steps in the loading of that particular resource. And now in most cases, we only look at ready state change equals 4, right? You check if ready state change is 4, which means the whole thing is loaded up, and then we do interesting things with it. But here we can do more things with the intermediate states. And then finally, I call the original apply method, the original open method with all the arguments that passed it. So the 5 ready state change. So if you look at document.ready state or request.ready state, you'll get 5 different values, 0 through 4. 0 really means it's uninitialized. So when you create that new XML HTTP request object, that's the only time it will be 0. If you call open, it's going to change the state to 1. That really doesn't mean much because you called open, but you haven't actually made the request, so you don't care about that state. 2 is when you made a request and you got the first bytes back, so the header has started coming through. So we sort of equate that to a response start. If you look at navigation timing, we have response start, that's when the first byte of the headers arrived. So we say, all right, 2 is when something is started coming back. 3 is typically when a lot of your content is available, so DOM interactive. And 4 is when your content is completed loading. So we call that equivalent to responsiveness. So we can do all these things with the ready state change, but with browsers that support resource timing, we can get more creative.
Why?
Because since we resolve the URL at this point, right, in that ahref is equal to URL, and the resource.url is equal to ahref, we've now resolved it to an absolute URL. So we can do something like performance.get entries by name and given that URL. And that will get us back a resource in the resource timing object, which contains all of these detailed timing information for that particular XML HTTP request. So we can tell how long it took to do a DNS lookup or a TCP connect, or whether it did a redirect, all of those things for that particular XML HTTP request, which is rich information. It's stuff that we could only get with navigation timing for a full page load. But using resource timing, we can pretend that this single page request was a full page and treat it the same way by getting all of that detailed information. All right. So, no. Sorry, it would be a boring topic to go over right.
It's not the boomerang.
Some people are a little disappointed. So it's 2015, right? Yes does not stand for simple page applications. It stands for single complex page applications. So it turns out the initial, in many applications, and we've seen this across all of our customers who use XHR, except for my blog, which uses XHR purely to test whether boomerang works or not. But everyone else who uses it, what they have is the first XHR actually loads XML or JSON, which just contains meta information. So it might contain, let's say you click on you're looking at an e-commerce website, you click the search link, right? Type in something, hit search, it goes ahead and fetches JSON data for that search result, which contains a list of products that contains product information, like price and description, but also contains URLs of product images. So then when you inject that into the DOM goes ahead and downloads all those images which you injected. Right? Now all of those actually make up the entire user experience. When the user clicks on that search button or clicks on the next page button, they don't care when that JSON loaded. Right? They care when that page was visible. Or when all of those images that they clicked on that they initiated have downloaded. So we want to be able to download all of that and measure how long it took to load that. It might also cause other style sheets to load. So for example, if you were on the product page and then you went to a checkout page, it might need new style sheets. It might need new JavaScript. So we want to know when all of that loaded. So all of these resources, the combination of them, starting from the user clicking something or typing something to when everything is complete, that's what we want to measure. And we need some way of proxying that, because that's when you look at a multi-page application, the user types in a URL to the time the onload event fires, everything else downloads, right? It's just the images, the JavaScript, the CSS. So how do we simulate what that person will be there? So there's something called a mutation observer. Is anyone familiar with the mutation observer? All right, 3 people. So I will explain it. So what a mutation observer does is it's a fairly new type of object that just watches the DOM and watches the DOM for mutations, which basically means has any new nodes been added to the DOM, has any nodes been removed, or have any nodes been modified. Right? And by modified it means has the children been changed or have attributes of that node been changed. Right? So these are all interesting things that we want to look at. And looking back at our product page example, you might have injected this whole new DOM element, which contains list items and images and all that on it. So you want to look for all those changes. Or when you click on the next page, it might change all the URLs of the images, and you want to look for all of those. So that's what we're going to do with the mutation observer. Again, this code is complicated. This is a fairly simplified version of just the basic observer. All it's doing is it's creating a new mutation observer here and calling the callback it's done whenever a mutation happens, and we set a timeout. So we do two things. We create a mutation observer, and you can see the rest of the code in this particular XHR. I'm going to explain what it does. So we start a mutation observer that whenever an XHR returns, not when the XHR is started, but when it returns, we start a mutation observer to see what DOM nodes have changed. And because we were capturing that open and all the events, we actually our mutation observer can run before any of the customer's code runs, or any of the page owner's code runs. So we can start a mutation observer before they actually start manipulating the DOM. Right? So we start listening when the XHR returns, and we set a timeout. So timeout of, let's say, 100 milliseconds. Right? If no mutations happen within 100 milliseconds, we'll assume that the XHR was the only thing that happened and nothing else. And we'll say, all right, that's fine, let's measure that and move along. But if something changes within that 100 milliseconds, we'll start looking at that. And we look for any things like scripts or images or iframes or link nodes that happen to have an href on them. Actually, link nodes that happen to be style sheets. So we look for any of these, and if we find them, we'll set a load and error event handle on those. And we'll also sort of write the timestamp to that node saying this is when that node first showed up on the page. So when those particular handlers fire, the load or the error event handlers fire, when all of the ones that were initiated from this particular request end up firing, that's when we'll say that request is completed. And we know that a particular JSON loaded, a whole bunch of images, style sheets, JavaScript loaded, and this is when it's completed. So we know all the resources that were included in that particular request, and we know how long it took for each of them to load, as well as the total time. Right? There are a few caveats here. We found it's inconsistent on whether cache resources actually fire all of these events, particularly in Internet Explorer 8. We found that cache JavaScript does not fire either a load or an error or a ready state change event. Right? So there's actually no way to know when JavaScript was loaded from cache in IE8. The problem is IE8 also does not support resource timing, so we're kind of left in the dark there. We might be just waiting for a long time, which is why that timeout is very important. So we also set a timeout on every single object, and if we don't see any response from it in a certain amount of time, we'll just say, all right, we don't know what's happening with that. The load event also does not tell you when the element became visible. So Steve Sanders actually has a very good blog post, so I'm not going to go into that, about telling when images actually became visible. So if you go to his blog, you can read about the hero image problem. The load event does not tell you when it was visible, it just tells you when it was downloaded from the network. Right? So that may not be your actual end goal. Like you mentioned for Intuit, you actually want to know when things were rendered, when the animation completed and stuff. And that may be true for most websites, so you may want to add more instrumentation there. But this gets you a fairly close approximation for a general case. Right? It gets you within half a second of timing. So instead of saying I have no idea when anything loaded, say, all right, I was 2.7 seconds, but it was actually 3 seconds. Yeah.
Which modern browser does not support mutation observer API?
Glad you asked.
Oh, you got it.
So mutation observer is supported by every browser, interestingly, including iOS Safari, but none of the current versions of, well, IE11 supports it, which is current. But there are still a lot of users on IE8, 9, and 10. So you see right up there in the top right corner, global support is 83.9% of users versus US, which is 86%. So you're still losing about 17% of your users. But remember, this was an enhancement over the original measuring of just XHR. So even for those other users, you'll still capture the XHR timing. For anyone that does have mutation observer, you'll also capture all of the other changes. Right? Problem is, it gets a little complicated if you have two or more concurrent XML requests. Right? You can measure how long each of them took to load, but you don't know which one initiated which images and JavaScript and stuff. So I actually don't have a good solution for this. What we do right now is when the first one returns, we'll start a timeout and we'll look at all the things that happened within that. So cool thing about mutation observer is it doesn't fire once for every DOM mutation. It fires once saying, these are the mutations that happened in the last instant. Because, I mean, the browser downloads things in chunks, right? So it'll do a whole bunch of things and then say, this is what happened. So we look at that, and if another XHR happens while that's happening, we will sort of terminate, we'll say, all right, all the resources that we've logged so far, that's it. And anything else that comes in is going to be part of the next XHR. And so that's a kind of approximation that we come up with for Boomerang. Right? It's the best that we can do without knowing the details of the page. We also watch, or we could watch, we don't do this right now, the history.pop state event. So a lot of single page applications, what they'll do is when they download content over XHR, they also do a history.push state to change the URL of the page without actually causing a new download. And this is good because it allows you to bookmark that URL or mail it to somebody else, send it to our IAM, which means somebody can click on that and it'll actually do a full page load. But what happens when the user clicks the back button is then rather than actually loading something from cache, it does a history.pop state. And typically what a single page application does is it listens for history.pop state, and then it loads up the state from maybe local storage or something, and says, all right, this is what my page needs to look like now. So we need to do the same thing. We need to trap history.pop state and say, all right, what's going to change now? Does this initiate any XHRs or not? We also kind of track any clicks on the page and wait again about 50 milliseconds to see that click initiated any downloads. Because sometimes people don't always use XML HTTP request to download content. Sometimes they use JSON-P, which means you click something, they inject a DOM node, a script node onto the page, and that downloads JSON, which then causes other images to load. So we track a click to see if that actually causes a script node to be injected into the page and then download things from there. So there's a bunch of things we do, and we're really good at software. But again, things are not that simple because a lot of people use frameworks, and every day we have a new JavaScript framework for single page applications coming out. The ones that we looked at in more or less alphabetical order. It also turns out in order of popularity. AngularJS, Backbone, Ember, React, and what was your favorite one which you want to add support for?
Meteor.
Meteor? Sure. These are the 1, 2, and 3 is what we have added support for because we have 3 developers in the team. It's an open source project. We actually got somebody sent in a message this morning, some guy from Bangalore saying, can you guys guide me? I want to write a React.js plugin. So they're like, yeah, great. So if you have your own favorite plugin, we'll help you to write a plugin for it. So we've got support for AngularJS. I'm only going to show you examples of Angular. Essentially, you cannot do much of what I spoke about. You cannot do because Angular does some very interesting things. It'll send multiple XHRs. It even starts its own XHRs before onload is fired. So you can't actually wait for the onload event to fire to do all these things. So what we do is we stop listening for any of the regular XHRs. Instead, we look for AngularJS routing events. And when these things happen, that's when we'll start the mutation observer. And that's when we'll start looking at any downloads that might happen. So you need to put this kind of code in your AngularJS app, which registers Boomerang with your AngularJS app and says, all right, I need to call out to this hook Angular Boomerang method, which there are 2 possibilities with when you're loading Boomerang. Boomerang loads asynchronously in a non-blocking fashion. So there's a chance that Boomerang will load after your page is loaded, or there's a chance that Boomerang was in the cache and it loads immediately. So you need to handle both cases. So the first case checks to see if Boomerang already exists on the page, and if it does, it'll just call the hook method, and if it doesn't, then it'll wait till Boomerang is loaded. So when Boomerang loads up, it fires an on Boomerang loaded event, custom event on the page. So you can subscribe to that event and say, when this event happens, that's when I want to go and register. So it kind of works in both cases. Now again, this is simplified code. This does not work in IE8 and older. There's more code to add here that actually makes it work in IE8. And And if you go to our website, we've actually got a blog post that explains in detail how to do all of this. So other frameworks are fairly similar. I was going to include the backbone code, but it turned out it was structurally almost identical. It was just like root scope and root change start. Those are the only things that actually changed. Everything else looked pretty much the same. So I haven't bothered doing that. I also haven't shown you the actual boomerang code that does this because it's available online. It's very easy to go through. But the cool thing is that allows us to do waterfalls for single page applications. So you don't just have a waterfall for your full page app, but when you click on that link that downloads JSON and then downloads various images and stuff, that actually generates enough resource timing information. And since we know the list of resources that are required, we can tell something like this, which is one of our developers' personal websites. He runs a gaming website, and a lot of his stuff is XHR based. So here, a user clicked on the home page, and then it went ahead and downloaded a bunch of things like downloaded something from aps.google.com and a bunch of other CDNs and stuff. So downloaded all of this after that request, and because these servers all have the timing allow origin header set, we could get fairly detailed information about it. So we could construct a waterfall for this particular single page request, which you could not traditionally do if you were just instrumenting your start and end times with the XHR or anything else. So we found that it was a very interesting thing. Another cool thing is because we are injecting all of this timing information onto the DOM itself. So when we see an object, an image object, we say when we first saw it. When we fire the onload event, we also say when it loaded. So it turns out we can actually do waterfalls for browsers that do not support resource timing, which turned out to be an extremely cool side effect. So waterfalls on iOS Safari, never seen before, actually work. And that's actually pretty much all I have. There are a few caveats about using window performance, because if you want to do any of this, you will end up using window performance. On Firefox 31, Beta 5 onwards, I haven't mentioned Beta 5 because most people on the release branch don't use it. But there are people still using Firefox 31. Just testing for window performance in an anonymous iframe will throw an exception. You don't actually have to do anything with it, just have to say window performance as an exception. And it's a very cryptic error message. There's no, they haven't actually translated the error message to English. It's just really like a constant that comes up there. Because they didn't expect it to ever be thrown, because they didn't expect anyone to ever do window performance in an iframe that does not have a body. Right? But we do, because we load boomerang in an anonymous iframe. So they said, we spoke to them file above, they said you need to do if window in performance. Oh, sorry, if performance in window. Now, who here uses JSLint? Does anyone use JSLint? Now, if you do this in JSLint, it complains. Saying, improper use of in.
Yeah.
So we did two things. We stopped using JSLint.
That's old. JSLint hasn't been updated.
We started using ESLint.
It's old, right? When was the
But
last
we also switched to using if window that has one property, because that's what Douglas Crawford says we need to use. Which is kind of verbose, but hey, it looks works, right? No, it doesn't actually work. Because it turns out Internet Explorer 10 window is a host object, and so it does not have as own property performance.
Yeah.
Right? Because performance, the string performance is a JavaScript string, but for Windows host objects you have to use a C string, which is not the same as a JavaScript string. And so that doesn't work, it just returns false. So we ended up putting a try-catch block with if performance in window and window.performance. Because we have to test two things, right? Window performance actually exists in window, and it is not falsy. So it might exist, but be null or undefined. So we ended up with this huge piece of code just to test, make all these browsers work.
How about type of?
No, it doesn't actually work. That's an exception. So we got all of this and we actually logged these exceptions, so we beacon them back to our server. So now we have a list of all browsers which throw errors in many of these cases. And that will actually make an interesting blog post about just various strange browser bugs found. Another weird thing about browser exceptions is Internet Explorer has exceptions in localized languages. So you cannot easily correlate different exceptions across browsers from different languages. So I think I know how to say undefined object in about 25 languages now. Well, I can write it out, I can't actually pronounce it. That's all I have for you, Sam. Thank you. Any questions?
I know someone's got the first question.
That's a catch points. What rank were you?
Huh?
What rank were you on the TP quiz?
Oh, that was just a velocity.
Right.
Yeah.
Velocity.
So my question is, how do you measure the animation that takes place, and what are the things that we should be actually caring about while measuring those?
Okay. So we can't automatically instrument animation. So that's not something we would do in the library itself. But it's something that you as a developer could do. Essentially, depending on how you're animating, typically you would use something like request animation frame. So you use something called a user timing API. So that's also provided by modern browsers, and there's a shim available. One of our developers actually, so Nick Jansma, he worked on the Internet Explorer team, and now he works in Boomerang. He's made a shim for user timing. You can use that in browsers that don't support it. Essentially, you can set different marks, saying this is when my animation started, this is when various frames happened, this is when my animation ended. And then what Boomerang will do is it will collect all that user timing information as well. So it will collect whatever timing information you can find on the page, and a whole bunch of other information. So right now I just spoke about measuring single page apps, but Boomerang measures a lot of other things. So essentially, if you do that, use user timing, you'll collect that, and you can analyze it. Either using your own log files, using Splunk, or using a server-side application that pulls it into a database and does analysis.
Well, it's interesting over there. One of the things to think about is Philip's got a large list of presentations he's given on SlideShare.net. I believe your profile is Blues Moon on that.
My profile is Blues Moon. These slides are also up. I put them on
Blues
Moon. So,
Blues Moon?
Yeah, I'll go back to my.
He's also going to follow on Twitter and everything else.
So right here, that's my Twitter handle, and my GitHub handle, and my SlideShare handle, and my speaker deck handle, and probably other services that I don't use. So if you go to Blues Moon or any of these, you'll see all my presentations. Speaker deck has some of them, SlideShare has some of them, so I'll be testing it.
My question was on WebSockets and whether you're taking a same look at that you are with XHR.
All right, so WebSockets are kind of a little different. It's not really an HTTP protocol, so it's more TCP based.
Yeah.
And there's also no well-defined end-to-end data frame. So it's really for streaming.
It's just
Yeah. So we haven't looked at it in detail, but one of the things we would consider is rather than look at how long it takes something to happen, look at the rate at which data is coming through. So really look at the throughput of the WebSocket rather than the actual time to download something. Right. And that's Boomerang actually has something called a bandwidth test, which is more correctly called a network throughput test, which measures the throughput of the customer's network. Let's say that the end user's network. So that does it by downloading images, but you could do the same using a WebSocket. Or well, there are several ways of doing it. But that's what we look at for WebSockets. Any other questions? All right.
Thank you, everybody, for coming to our first BayJax thing to it. We hope to have more, and thank you again to Blues Moon, Phil Tellis.